Is my screen visible?
Yes, sir.
The previous class we were discussing about why the efficiency of the Carnot cycle is higher than the efficiency of that Rankine cycle. So we have discussed till here that you were having why it is higher, na? Okay, then we'll discuss that. Instruction. As we all know that efficiency of the cycle is given by 1 minus Q heat rejected upon Q heat supplied. Okay. So can we write del Q in terms of entropy? Entropy we know that delta S is given by Q upon T entropy. So from here we can write entropy in terms of this only. So Q rejected can be written as T lower because even though the cycle is different, but first I'll draw that diagram. Q supplied TL into delta S into T higher into delta S. Okay, so this is Rankine cycle. Okay, we'll mark 1, 2, 3, 4, 5, 6. Okay, so this is the higher temperature T higher. This is T lower. Okay, so the temperature at which heat is rejected, it is same for both the cycle, therefore we can write T though, so the mean temperature of heat rejection will be same, that is T lower only. Mean temperature of heat rejection will be is equals to TL only, because for both the cycle, that is a Carnot cycle, which is the Carnot cycle, 1 2 3 6 1, and Rankine cycle is which one? Hello.
124561.
1 2 4 5 6 1. Yes, this is our Rankine cycle. Okay, so mean temperature of heat rejection, it is same for both Carnot and Rankine cycle, but the mean temperature of heat addition uh, is different for uh, for both the cycle actually. What is the mean temperature of heat addition for Carnot cycle? Hello, can anyone tell?
T higher for Carnot, T6,
Yeah,
T1.
and for Rankine cycle, I'll write Carnot CRNOT, and mean temperature of heat addition for Rankine cycle, what it will be?
T1 plus T5 by 2.
Yeah, T1 plus T5 by 2. So when we will draw this on this curve,
Sir, it will be greater than T1 plus T5 by 2.
no, it will be mean of it. I'll wait. I'll show you. No, 3, 4, 5, 6. Okay. So what will be the mean temperature of heat addition for this? It can be write like this. This area will be our represented, but in case of Rankine cycle, what it will be? It will be somewhere here. So mean temperature of heat addition. This will be, so it is somewhat lower. This is for Carnot cycle, and this is for Rankine cycle. Now is it visible? So what we can write? Efficiency as 1 minus, because mean temperature of heat rejection is equal to TL only. So we are writing that TL only, and mean temperature of heat addition here we have to take for Q supplied. So mean temperature of heat addition into delta S. Okay, so delta S will cancel out each other, and what will remain? Mean temperature. So efficiency will totally depend upon mean temperature of heat addition here. So 1 minus T lower upon T mean. Oh, and for Rankine cycle, it is lower. Rankine, it is lower, and T mean for Carnot is higher. Okay, therefore efficiency T mean for it is higher for Carnot cycle. Therefore this whole term will decrease, and efficiency will increase. Okay, but even though the efficiency of Carnot cycle is higher than Rankine cycle, but the network output of which of this cycle is higher?
Rankine cycles.
Yeah, why?
नो सर रैंकाइन का कहाँ है?
Yeah, Rankine will have a higher network output. Wait, I'll show you how.
ओके दिखा दीजिए.
Work net of Carnot. Okay. Five. 3 dash. Okay. So network. What is the network is equals to? That this turbine.
Area under.
No, turbine work minus compressor work. Work turbine minus work compressor. Okay. So what it will be? H1 minus H2 minus S3 minus H4. Okay. So this compressor work in case of Carnot cycle is higher than compressor work in case of Rankine cycle. So because of this, what will happen? The network output, even though the turbine work is same, that is turbine work is same for both the cycle, that is H1 minus H2. The difference is coming in case of compressor work. For compressor work here, what will be the compressor work for Carnot cycle? That will be H5 minus H3 dash. Okay, which is higher than H4 minus H3. Okay, that's why wait, yeah, network output. That's why network output of Rankine cycle is higher than network output of Carnot cycle, but efficiency is lower. Okay. Hello.
ओके सर.
So these two statements also I should write. So Carnot cycle is higher than Rankine cycle. Okay. Now we will start discussing about how the different method. First, I am thinking of completing all the theory portion. Then we'll discuss all the numericals. Okay, is it fine for you?
Yes, sir.
Okay. Okay. So now we will discuss various methods to improve Rankine cycle. Okay. So what are the different methods by which we can increase the efficiency? First method is by increasing the
हीट एडिशन.
Mean temperature of heat.
Heat addition.
by increasing the boiler pressure. Okay. Second, what is the second method by which we can improve? By decreasing the condenser pressure.
Sir, in the practical scenario, the lowest possible condenser pressure is used is
Lowest possible. Lowest possible. I actually don't know, but I will tell you in the next class after reading those books. But they don't ask such type of questions in the GATE exam. They generally ask numerical part only from this or effect of what will be the effect if will decrease the condenser pressure, increase the boiler pressure. These are type of questions they generally ask in the GATE. They doesn't ask you values.
So shouldn't it be above atmosphere because leakage will start? Is it true like that?
Yeah, it should be above atmospheric pressure, but uh, that that I have to see. Then I'll tell you after in the next class that I'll tell you. First, we will discuss these effects. What their effect will be. What will be the third? Third by superheating. Fourth by reheating. Okay. What will be the fifth? Fifth will be what we have discussed in the gas turbine.
Regeneration.
Yeah, regeneration.
Sir,
Yeah.
sir, can you kindly tell what we have done till now? Because right now only I was able to join.
We have just only discussed this part only, why the efficiency of Carnot cycle is higher than the Rankine cycle, and even though the cycle of Carnot cycle is higher, but the network of Rankine cycle is higher. That till that portion only we have discussed.
Okay, sir. Thank you, sir.
Okay. So we will discuss all these one by one. Okay. So first we will start with in case 1, that is by what will be the effect if we are increasing the boiler pressure. Boiler pressure. So this is fine. Okay, we are increasing the boiler pressure. Dash, 2 dash, 4 dash, 5 dash. So it is initial PV1, it is PV2. So you tell what will be the effect. So what you can see from the diagram. STS curve. This is our first cycle. 1, 2, 3, 4, 5, 1. And this is our new cycle with pressure P2, higher pressure. 1 dash, 2 dash, 3, 4 dash, 5 dash. Okay. And then again 1 dash. So what will be the effect on the network output? Turbine work.
Turbine valve will increase.
Increases.
Yeah, it will increase. Previous it was H1 minus H2 and now it is H1 dash minus H2 dash. So clearly it is increasing. What will be the effect on the pump or compressor work? This is you can call pump or compressor.
Increases.
But
Yeah,
not as significant as turbine.
Yeah, it will also increase. What will be the network output?
It will increase.
Yeah. Why it will increase? Because even though pump work is also increasing, but the turbine work is increasing in a considerable manner. Okay, that's why the network output will also increase. What will be the effect on the heat supply?
Increases, sir.
Heat supply.
Increase.
Mm, heat supplied.
It will decrease.
No, we can't say anything about that. I think so. But wait. Pressure is increasing.
Sir, it will decrease, no, sir.
No, we can't say anything. We have to calculate it. What will be the effect on the heat rejection? Because similar the amount of work here it is decreasing this portion. Na? Similarly, this portion is also increasing. So we can't say that this portion is higher or this portion is lower. So we can't predict right now that heat addition. This is the additional and okay.
Yes, sir.
So what will be the heat rejection?
Decreases.
Yeah, it will decrease. What will be the mean temperature of heat addition?
Increases.
Yeah. What will be the mean temperature of heat rejection? It will remain
Repeat, sir.
constant. It will not change.
Sir, why, sir?
See, from here you can see na, heat is rejected at the same temperature. That is lower temperature. So even after increasing the boiler pressure, the heat is rejected at the same temperature T lower only. That's why it is remaining constant.
Okay.
What will the effect on the that efficiency?
Can't say.
Yeah, because we don't know how much is the heat supplied, because net efficiency is work net upon heat supplied. Even though work is increasing, but we don't know about the heat supplied. That's why we can't predict anything for that. What will be
But
the
sir, the mean temperature of heat addition has been increased.
yeah
So, and the efficiency will be 1 minus TL by T mean heat addition.
yeah right, yeah, you're right.
So why, why,
Efficiency will increase. Sorry, QS upon QR upon QS. So that will be T lower will be same del S, and the mean temperature of heat addition del S. Del S will cut out each other, and because mean temperature of heat addition is increasing, therefore efficiency will increase.
so, so sir from this we can मतलब इससे derive कर सकते हैं कि जो मेन हीट एडिशन जो है ना QH वो भी इंक्रीज ही किया है.
That actually I cannot say anything about it, because we have to look into the area also now, which is this is this significant, because significant increase is there or not, that we have to see
सर
first.
सर एक चीज पूछनी है जो TS डायग्राम में वेपर डोम है
हाँ
उसमें जो स्लोप होता है वेपर साइड वाले का
हाँ.
वो लिक्विड साइड वाले के कंपैरिजन में ज्यादा होता है कम होता है.
कौन सा स्लोप बोल रहे हो?
ये वेपर डोम का जो वो है ना जो ऐसा जो पहाड़ है तो
नहीं
उसमें
वो वो रहता है, दोनों सेम ही रहता है एक्चुअली में. ऐसा रहता है, एकदम सेम रहता है,
और
सिमेट्रिक सिमेट्रिक रहता है एकदम इस टाइप का दोनों
पर
साइड.
पीवी डायग्राम में उसका स्लोप ज्यादा होता है और इसका कम होता है, लिक्विड का ज्यादा होता है ना पीवी डायग्राम में।
हाँ, ऐसा रिप्रेजेंट करते हैं। कांस्टेंट प्रेशर लाइंस को बोल रहे हो ना तुम?
नहीं नहीं, मैं वेपर डोम के स्लोप की बात कर रहा था केवल।
ये वाला ना, ये?
हाँ, ये जो मतलब जो पहाड़
नहीं
का जो
नहीं, सिमेट्रिक रहता है वो।
के साथ, पर प्रेशर और पी वर्सेस वी डायग्राम में तो स्लोप डिफरेंट होता है ना।
स्पीड डायग्राम में क्या?
पीवी डायग्राम में वेपर डोम का जो दोनों लिक्विड साइड और वेपर साइड का स्लोप है वो अलग अलग होगा ना।
मेरे को यार पीवी डायग्राम याद नहीं है, लेकिन मेरे को टीएस डायग्राम का याद है। टीएस डायग्राम में दो सिमेट्रिक होता है ये।
ओके सर, ओके सर, थैंक यू
पीएस पीएस डायग्राम में टिल्टेड होता है।
नेक्स्ट क्या था अपना? ड्राइनेस ड्राइनेस फ्रैक्शन पे क्या फर्क पड़ेगा?
सर। ड्राइनेस फ्रैक्शन रिड्यूस हो जाएगा।
हेलो सर, इन इफिशियंसी के फॉर्मूले में डेल्टा एस कट कैसे हुआ? वो तो अलग अलग है ना।
क्या?
फ्रॉम दैट इफिशियंसी फॉर्मूला हाउ डेल्टा एस गेट कैंसल?
इंट्रोप ट्रॉपी no, it will remain same, it won't change actually in entropy. You just remember this actually. This I have to see actually. Just remember this formula actually. 1 minus T lower upon T mean temperature of heat addition. This will T mean temperature of heat rejection. Okay. From here we will get that, because it will remain constant and it will increase. That's why it will efficiency will increase. Okay.
Sir, usually always we compare efficiency based on this formula only, right, sir? And not based on
No,
W
no.
on
For this
Q.
case only we are doing with this formula. Actually, we can't predict about that heat supplied actually. That's why actually it should increase. But in the books from where I have prepared the notes, they are saying that it won't, that heat supplied we cannot predict anything. That's
So
why,
actually, because in some cases, like when we compare using this work net formula,
yeah.
it's a bit confusing. So like so, um, well, for comparing the efficiency.
Efficiency, you should just remember that only, this formula. 1 minus Q rejected upon Q supplied. This, or network upon, this is also, you can remember, work net.
That's
But
what, like when we'll use, like is it interchangeably used or based on the case?
no, if you will calculate by this or this, same answer will come. It is only different versions by which we can represent this. 1 minus Q rejected upon Q supplied. These all are same. Your answer won't affect by this.
Okay, sir.
So dryness fraction, what will happen? Dryness fraction will decrease. X2 dash will be lower than X2. Okay. Second we will discuss what is second. What will happen if we will decrease the condenser pressure? Okay. First I should. This is PC1, this is PC2. 1, 2, 2 dash, 3, 4, 5, 3 dash, 4 dash. Okay. Volume pressure will remain constant. So what will be its effect? on the turbine work?
Increases.
Yeah. That pump work?
Increase.
Yeah, it will increase. So what will be the effect on the network output?
It will increase.
May
Yes?
increase or decrease.
No, network output will increase. The same reason that turbine work increases much higher compared to pump work increase. Okay. It is also increasing, but I have mentioned it. It will be a small increase in the pump work compared to turbine work. Therefore, turbine work will be higher than the compressor work increase. Therefore, the network will also increase. What will be the effect on the heat addition here?
Increases.
Increase.
Yeah, heat rejected.
Increases.
Here also we can't say that we have to calculate. Mean temperature of heat addition. Hello.
Decreases.
सर
Decreases.
हीट
Yeah.
रिजेक्शन तो इंक्रीज किया
Yeah. Similarly, like the previous case, na. Here also we cannot predict right now.
यहाँ पे कांस्टेंट टेम्परेचर पे हो रहा है टी डेल्टा एस
हाँ
ओके हाँ ठीक है सही है सर
हो रहा है लेकिन अभी अपन प्रिडिक्ट नहीं कर सकते उन्होंने वो उसके लिए अपन को पूरा ड्राइनेस फ्रैक्शन वो सब हर चीज़ कैलकुलेट करना पड़ेगा फिर हीट रिजेक्टेड इस पार्ट का और इसका दोनों कैलकुलेट करके देना देखना पड़ेगा कितना सिग्निफिकेंट होगा या इक्विवेलेंट ही होगा दैट वी हैव टू सी बाय कैलकुलेशन ओनली वो व्हाट विल बी द इफेक्ट ऑन द मीन टेम्परेचर ऑफ हीट रिजेक्शन
रिड्यूस
Decreases.
या इट विल आल्सो रिड्यूस and efficiency
इंक्रीजेस
why it will increase
We can't say
yeah
no, sir.
can't
Both
say
decrease.
here we cannot say anything on the efficiency actually because both the mean temperature of heat addition and heat rejection both are decreasing so we have to calculate it on the basis of calculation only we can say that whether it will increase or decrease okay and dryness fraction what will be the effect
रिड्यूस
yeah dryness fraction reduces why it will reduce because the dryness fraction line in this region are represented like this okay so x2 is higher than x2 dash now third case we will discuss superheating so what is superheating
Increasing the quality of the steam in the boilers.
yeah at what
Above the saturation
yes
saturation vapor
yeah
line.
yeah you are right what is superheating superheating is the process by which we are increasing the temperature of the saturated vapor this is saturated vapor here so what we are doing here wait I'll show you saturated vapor at constant pressure okay so what will happen it I'll show you you know that constant pressure line are represented straight in this inside this dome region and here and outside that they are represented in the form of tilted line okay so what will happen we are increasing the first we will represent the first cycle of one 2, 3, 4, 5. So we are increasing the quality of the steam at constant pressure. So what will happen by increasing the temperature? So if we will increase the temperature here, so what will happen? Like this, or here we can say that anything can happen. So if this we are taking that 2 dash, and rest will be remaining the same. So first cycle, this is condensation pressure, this is the boiler pressure. Okay, so you tell one by one what will be its effect. So 1, 2, 3, 4, 5, 1, it is the normal cycle, normal Rankine cycle, and 1 dash, 2 dash, 3, 4, 5, 1 dash, it is the superheated Rankine cycle. So what will be the effect on the turbine bar?
Increases.
Yeah, it will increase. Compressor work?
Remain same.
Yeah, compressor or pump work, that is same. So what will affect? Constant. Yeah. What will be the effect on the network output? It will increase because turbine work is increasing. Heat supply,
Increases.
here it will increase because temperature of the steam we are increasing. Okay. So heat rejected, what will be the effect?
Increases.
Yeah.
Increases.
And mean temperature of heat addition?
Increases.
Yeah. Temperature. No, we can't. Mean temperature of heat addition, it will remain constant, I think.
So that is mean temperature of heat addition is
Yeah,
supplied into saturated liquid with
yeah, it will increase actually because we have to take on the both side. Wait, I'll show you. Mean temperature of heat addition. On both side we have to take, because here it was constant temperature previously, so we were writing T4 plus T5 by 2, but now what will happen? Here it is not constant, it is also increasing. Okay, so here it will increase actually. So what will happen? T4 plus T5 by 2 plus what will be the, from here also it is increasing, so what will be? T1 plus T1 dash, or you can write T1 and T5 temperature is same, so we can write T5 plus T1 dash by 2, because this part is actually increasing, therefore mean temperature of heat addition will also increase. Previously in that normal cycle, what was happening? Only this portion was here, it was constant, that why it was its effect was not seen, but here it is also increasing now, so we have to take this portion also into account. That's why the mean temperature of heat addition will also increase. So what will the effect on the mean temperature of heat rejection?
Same.
Constant.
Yeah, constant. Efficiency?
Increases.
increase.
Yeah, same, because of the mean temperature of heat addition is increasing. Dryness fraction?
Increases.
Yeah, increases. Previously it was here, so we will draw these lines. This point can be on this also, or below also, it can anything, anywhere it can occur, but from here we can see it is actually increasing. So x2 dash is higher than x2 here. Okay.
Sir,
Yes.
that the mean temperature of heat addition means the temperature at which feed water enter into the boiler,
Yeah.
not at the. But in this case, we consider the at
Because here heat, this is also heat addition only, na, this portion. This also we have to take into account. This is this this temperature increase and this temperature increase, both we have to consider at the same time here. We have considered
Okay.
only till this portion. This portion we have not considered. This portion also now we have considered here. Previously, because in that cycle this temperature was constant. That's why we were only writing T4 plus T5 by 2. But now because this portion is also a heat addition, so this portion also we have to take into account, because of which it will increase.
Okay, sir.
Okay. Now, fourth, what we have discussed, reheating. Why reheating? So in the gas turbine we have discussed. What by reheating, what happens? What is the effect?
Network turbine work output increase.
Yeah, turbine work we are increasing. Turbine work we are increasing by what?
By supplying the additional heat.
Yeah, by supplying heat addition. Okay. So what is reheating? What is reheating? Can anyone tell me the definition? We have already discussed.
Expanding steam to intermediate
Yeah,
pressure and again superheating it.
yeah. Reheating means expanding the working fluid. What is the working fluid here? It is vapor in more than one stage. One, or it can be more than one. Okay. So, what is the aim? What actually we want? Because we are in the previous case we were discussing about the air was our working fluid, but here it is vapor. So, what actually we want to increase?
Turbine work output.
Yeah, that is the one of the
Enthalpy of
reason.
working fluid.
Actually,
Brightness reduction.
actually, what we want that we by reheating we want to increase the quality of the steam, quality of steam entering into the
Condense.
into condenser, not turbine.
Turbines.
uh, and wait, steam exiting actually, exiting outside, out of the turbine. Why we want? Because if the steam coming out of the turbine, that is the steam which are coming, if it's it will be in vapor form, it will have a dryness fraction, higher dryness fraction. So what will happen? It will create the turbine blade erosion will occur. Okay, at the exit, at the exit of turbine. So for that, what we want? We want that the quality of the steam, it should be in vapor or superheated, anything it can happen, but it should be, we actually want to, previously in that cycle, what at the exit we are getting this uh, uh, wet region we are getting steam. So at the exit it can damage, it can corrode, actually it can cause corrosion of the turbine blade. Okay, so that this we have to stop. For that, what we will do, we can reheat the cycle. Okay, or we can by reheating, what will happen? The quality of the steam, if it is, yeah. Now the quality is improved. I have just that generalize I have written. Previously it was like this. Okay. After reheating, that is reheating. Okay, this is also reheating. Actually, this is reheating only. So what happened because of reheating? Previously it was x2, 1, 2, 3, 4, 5. Now 1, 2, 3, 4, 5. So the quality of the steam here x5, it is higher than x2. So the chances of the erosion and corrosion of turbine blade will decrease. Similarly, in this here also it will because the quality of the steam coming out of the that turbine is improved. Here also erosion of turbine blade is decreased. Okay, because if it will be in wet region, it will consist of water particles also, which can cause the corrosion. But steam, it does if it is in vapor or superheated form, it does not cause any corrosion. Okay, it causes corrosion, but its damage is little bit less compare very less compared to that liquid or water. Okay, so what will be the effect? Hello.
Yes, sir.
So what will be the effect of that reheating? And draw here also that. See, 7. Previously it was like this: 1 dash, 2 double dash. So 1 dash, 2 double dash, 5, 6, 7, 1 dash. It is normal Rankine cycle, and 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 1. It is reheated Rankine cycle. So what will be the effect on the turbine work?
Increases.
Yeah, compressor work, compressor or pump work.
Remains same.
Yeah, same. Network output.
Increases.
Yeah, it will increase. Heat addition, QS, it will increase. Why it will increase? Because we are increasing this part. This is also increasing. So because of that, Q supply it will also increase. Heat rejected,
Increases.
yeah, it will increase. Mean temperature of heat addition,
Increases.
actually we can't say that. It can also increase or decrease. Both can happen. Why? Because previously it was like in the first cycle, but here this temperature we don't know. At this point we don't know, na? So this point, based on this point, we can say that mean temperature addition, it can increase, it can decrease. First we have to calculate this point temperature, then only we can say that. What will be the mean temperature of heat rejection?
Constant.
Yeah, Efficiency,
Can't say.
yeah, it can increase also or decrease also. That we have to calculate, and that based on that we can say that. Dryness fraction,
Increase.
Increase.
yeah. So X4 will have higher than X2 will have.
The mean temperature of heat addition we can't say. No?
We cannot predict actually right now. It can, because this temperature we have to know. It can, this temperature can be even low that than this point also, 6 point also. So it can come here also, here also. So we cannot say. First we have to determine this point. Based on that only we can say that it will increase or decrease. Because if it will be lower, even though the quality will improve, but the mean temperature of heat addition will decrease na in that case.
Yes, sir.
So we cannot say. We have to calculate this point 2, and based on point 2 we will get the temperature of point 3. Actually, that also we have to calculate, but the main point is 2 only. It will depend on this point whether it will increase or decrease. Okay.
Yes.
Okay. So um, we'll try to do one or two problem, because a lot of theory we have done. So we'll do one or two problems so that in the next class we will discuss the regeneration. Okay.
Okay.
And directly drawing the cycle actually. Uh, Wait, I no, I'll not draw. You have to draw and tell each and every point. Okay. I'm writing the question. Water is fluid in Rankine cycle. Saturated vapor enters the turbine at 2 megapascal temperature, pressure, and the condenser pressure is given 10 kilopascal. Okay. Pump work is negligible. We have to determine efficiency of the cycle. Okay. We give the data at 2 megapascal. Till the time you can draw the figure, I will not tell you. If I'll tell you, then I'll tell you after 5 minutes. Actually. 5 or not writing it is having same unit meter to can anyone tell what will how will the cycle look like? Because here I have mentioned about that steam entering the turbine condition of the steam which is entering the turbine. So it will be same as what it will exit from the boiler.
Normal Rankine cycle.
Yeah. So what I have told that steam is entering at saturated vapor. The turbine like this, 1, 2, 3, 4, 5. Now you can calculate efficiency. What will be the efficiency? It is easy.
Double unit by its applet.
Just here you can directly calculate because pump work is giving negligible. So net work upon heat supplied. So because pump work is negligible, so this we can calculate 0. So what it will come then? Efficiency will be equal to turbine work upon heat supplied. Because pump work in the question they have mentioned it is minimum. So now can you calculate? First you have to calculate the efficiencies at each and every. Efficiency of the enthalpies at each point 1 2 one of not all points you just need the enthalpy where so turbine work is h1 minus h2 and what will be the that heat supplied h1 minus h1 minus h4. Okay, so you have to calculate 1 2 4 enthalpy of these points you have to calculate, then you can determine. I'll give you 5 minutes to calculate the efficiency, then I will discuss this.
The 30%,
30 point,
30.14.
yeah, it is right. It is 30.2, you can say 14. So it is 30.2%. So anyone else who has got the answer? It is very simple question actually.
Sir, since we have neglected the pump work, like we have taken the enthalpy of heat addition same as that one. So like H1 is equal to H2. Like.
What pump work is, it is given minimum. Wait, I'll give you one more hint so it will become easy for you. Pump work is negligible, so you can count 0. Okay, so what is pump work? H3 minus H4. So enthalpy at H3 and H4 will be same. So your calculation time will be saved after that.
Yes.
Now what you need, just you need the enthalpy of 0.2. Once you get that, you can easily calculate. You have already got the enthalpy for an what will be the enthalpy of 0.1? It will be equal to Hg at 2 megapascal pressure. Okay. So what will it, what will be its value? 2799.1 kilojoule per kg. Okay. And steam at 0.3 at the pump, it is on the saturated liquid line, so it will be equal to HF. Okay, so S3 will be equal to H4. What it will be equals to? HF at 10 kilopascal, because it is on the saturated liquid line. So what is the value?
190.
Yeah, so what it will be? 191.81
81.
kilojoule per kg. So we directly write H4 here. Now just we have to calculate 0.2. It is only missing for the efficiency. So for 0.2, what we have to do? Because 1 to 2 process is
Isentropic extract.
isentropic process. Yeah. So S1 is equal to S2. From here we have to calculate the dryness fraction of 0.2. What is the dryness fraction? Wait, I will 0.759.
0.759.
Yeah. So at point it will be equal to saturated vapor Sg of 0.1. It is Sf2 plus X2 into Sg2 minus Sf2. Actually, so what Sg1? What is the value of Sg1? 6.34. 6.3468. SF 0.2 it is it is at a pressure of 10 kilopascal. Okay, so we have to take all the values. So wait, I write here also. These condenser pressure 10 kilopascal, and this is the higher pressure, that is 2 megapascal. Okay, so we have to take for that 10 kilopascal. So what is the value of SF2? 0.6492 plus X2 into 8 point. Similarly, this also we have to take for 10 kilopascal. 8501 minus 0.6492. Okay, from here what we will get? X2 0.7596. It will equal to 0.76. You can write. Okay, so enthalpy of 2 now you can directly determine HF2 plus X2 into Hg2 minus Hf2. What is the enthalpy you have got? 198 plus 76. Can anyone tell what is the enthalpy?
2009.369.
Yeah, 0.4 you can write directly. So you have got, just put these values here, H1, H2, H4, you will get the efficiency. That will be 30.2. Should I do that also, or you can do that?
We can do that.
Now we'll discuss one problem that conventional type of problem that will consist of both superheated cycle as well as a reheat cycle. Okay, if you able to do this problem, then other problems of the gate you can also do. action and steam is working fluid in cycle with superheat and heat steam enters the first stage of turbine. Here it is dot actually. Here from next steam enters the first stage of turbine. Superheated state at 8 megapascal pressure and 480 degrees Celsius, having enthalpy is equals to 3348 kilojoule per kg and entropy is equals to 6.6586 kilojoule per kg Kelvin. Okay. Then after that what happened? It is then expanded or expands to a state of 0.7 megapascal pressure, having these values. I am writing these values for this SG 22.78 kilojoules per kg Kelvin, HF 697.22, HG is to 2066.3. It is then reheated at constant pressure, that is 0.7 Pascal, heated at constant pressure considered to a temperature of 440 degrees Celsius. ठीक है, temperature of 440 degrees Celsius, having enthalpy H seven, 6. Now it is reheated. Now after that it is again expanded to a pressure of 0.008 megapascal, having such 526 SG 1.87 then SR HG 170 88 2
So what is SF?
What?
SF, what is SF? 0.008 MQ.
These are the values of the entropy, saturated liquid, saturated vapor, saturated liquid, saturated vapor. These are entropies. Okay.
What is the value, sir?
Values I have written now.
0.5296.
Yeah, 5296 kilojoule per kg. Units, both of them are having same. That's why
And
I have
SG, sir.
SG is the entropy of the saturated vapor.
वैल्यू सर नहीं समझ में आ रहा क्या है वैल्यू.
It is 8.
Okay, sir. 8.
8.2287.
Okay.
So assume specific volume that is VF of these here for that pressure you have to specific volume we should assume that
Oh, sir.
yeah.
Sir, HJ value 29 or 24, sir. 2903.1 or 24, sir.
Where?
The above step.
HG value, sir.
HG 2403 it is.
Okay. Thank you, sir.
Wait, I'll write.
So what we find?
Wait, question. I have to complete the question first. G 2403.1. Is it now visible? And specific volume of the saturated liquid
Sir,
volume. Yeah.
sir, and also ST value, SF value, it not clear visible, sir.
Which value?
SF above
This
step.
This one.
Yes, sir.
0.5296. Is it visible now?
Yes, sir. Thank you, sir.
3. Okay. One thing also it is check. Right? The cycle generates power output of 100 megawatt. Okay. So what we have to determine? First, efficiency of the cycle. Second, mass flow rate of steam kg per hour. Third, rate of heat transfer from the condensing steam as it passes through condenser in megawatts. These three you have to find. So first you have to draw the diagram, how it will look like. Hello.
Yes, sir.
Can anyone draw how the that figure will look like?
earlier. Experiment.
So first, what will happen? It is said that steam enters. Steam is entering in the first stage. In the first stage of the uh, first entering in a superheated state. So what will happen? Because it is mentioned it is in a superheated. Now after that it is expanding. Okay. So this is point 2. After that it is what it is mentioned in the question. Then it is reheated at constant pressure. It is intermediate pressure 0.7 megapascal and our temperature is 8 megapascal. It is 8 megapascal. Okay. Now it is again expanded. Okay. Now 2.008 megapascal. Okay. After that, what it is mentioned? Nothing. Just it cycle will be completed like this. So 1, 2, 3, 4, 5, 6, 7. So according to question, what are the values they have given? They have given first at point 1 they have mentioned the enthalpy, that is H1 they have mentioned in the problem. What it is the value of H1? 3348 kilojoule per kg, and S1 they have mentioned 6.6586. Okay. Similarly, at what they have mentioned at point 3, H3 they have mentioned. What is the H3? 3353.3 kilojoule per kg, and S3 they have mentioned 7.7571. Okay, I'm not writing the unit weight, I'm writing so that it may not. Okay, so these points they have mentioned that also power input. What will be the power net power output? They have mentioned it is 100 megawatt. Okay, so other points we have to determine. So can you do that, or should I do this problem? Hello.
Yes, sir.
Should I give some time to you to calculate, or should I do directly?
We are doing, sir.
Okay, okay. So these points they have given, and you have to based on this you have to calculate other point. That is, you have to determine enthalpy at point 2. H2 you have to determine. H4 you have to determine. H5, S6. These all points you have to determine. You have to calculate. After that you can calculate that will be and all. Little.
Hello, sir.
Yes.
Nothing, sir.
We need this data.
Sir, HF is equal to 173.8.
Yeah. What?
What is that value after 173 point?
173.88. Hello.
Yes.
Hello.
Yes, sir.
Yeah. It is 173.88. Has anyone got any one of the answer? Efficiency or mass
Is
flow?
efficiency 6.5%?
Efficiency 6 point?
5?
No. Wait, my call is coming. I'll take it. I'll continue after 1 or 2 minutes. Okay. हेलो सर मैं अभी आपको 2 मिनट 5-10 मिनट बाद कॉल करूँ थोड़ा मेरा लाइव सेशन चल रहा है जी सर हेलो हैज एनीवन गॉट अदर आंसर efficiency is not 6.5%. It will be close to 50% somewhat. Should I do if you are not able to do? Hello?
Yes.
Okay. Okay, then I will start. Okay. So enthalpy of point 0.1 it is given and entropy is also given. So this is a turbine work 1 WT1. This is WT2. Okay. So expansion is turbine is a isentropic process. So what will happen? 1 to 2 is isentropic process. Okay, isentropic process. So S1 is equals to S2 and entropy will remain same. Okay, hello.
Yes, sir.
So at 1 it is already mentioned in the question what it is, 6.6586 and point 2 it is at a pressure of, these values we have to take it as a pressure of 0.7 megapascal. Okay, so at 0.7 megapascal, what are the other values they have given? They have given it will, since
Sir, efficiency is 52.734.
no, it is 49.7 because here
Okay.
what you have taken at this point, have you taken it as a saturated vapor?
Yes, sir.
No,
नो
this
नो,
is
आई मैंने यहाँ पे इसको पंप जो वर्क है
हाँ,
इसको यहाँ पे लिक्विड लिया है और मैंने वो पंप वर्क भी उसमें वो किया है इवेल्युएट.
हाँ, पॉइंट टू इस बार अब हमारा जो केस है इन दिस प्रॉब्लम, पॉइंट टू विल नॉट बी अ saturated vapor. This we have to calculate first, saturated vapor, whether it is saturated vapor or not. For that we have to calculate the dryness fraction. If it will be less than 1, then the liquid will be wet and it will be greater than 1, then it is what then it will be in superheated region, and if it is equals to 1 then it will be a saturated vapor. So first we have to calculate the dryness fraction at point 2. Okay, so what will be the dryness fraction for that? Sg2 minus Sf2. These values Sf and Sg2 they have already given in the question. So from here first we have to calculate the dryness fraction at point 2. Based on that, we can say we can assess the quality of the steam at the after the expansion in the turbine 1. So what it will be, 708 minus 1.9922. So what it will come? Can anyone tell?
0.989.
0.9895. It will come. Okay. So what it means that at point 2, at 2, steam is wet. Yeah, now we have to calculate the enthalpy at point 2. Some of you might have already taken that point 2 is in saturated vapor, but it is not here. So it will come somewhat below it, somewhat here. Okay, close to that saturated vapor line, it will come. So H2 we have to now calculate. What is the formula? HF2 plus X2 into Sg2 minus HF2. So what will be the value? 697.22 plus 0.9895. What will be the value of H2? 2066.3 minus 697.22. So what will be the value of H2? 2051.93 kilojoule per kg. Now again they have mentioned what is the value of H3. They have mentioned in the question. What is the value of H3? 3353.3 kilojoule per kg. Now because from 3 to 4, what it is in? It is also an turbine work and it is an isentropic process. So again S3 will be equal to S4. Will it be? So S3 they have also given in the problem. What is the value of S3? S3 they have given 7.7571 kilojoule per kg Kelvin. So S3 will be same and S4 will be at a pressure of, we have to take all the values at a 0.008 megapascal. Okay, so 7.7571 757 because in turbine after expansion in turbine 2 the steam is expanded to a pressure of 0.008 megapascal. So these value we have to take here. Again we have to determine those values only. SF4 plus X4 into SG4 minus SF4. So 7.7571. What will be the value of S3? SF4 at a pressure of this 0.008 megapascal. These value we have to take here. So what are the value? 0.5926 plus
So the
X4.
mass flow rate, will it come as a huge value?
Yeah, first we have to calculate it. We will get it in terms of kilojoule per second. Then we have to convert in kilojoule per hour by multiplying it with 3600. That I'll tell you. What you have got actually mass flow rate. Hello.
So 1,55,052.
Yeah, it is close. I'll tell you. So X4 8.2287 minus 0.5926 0.5926 it is. So what is the value of X4 we will get here? 0.93.
989.
Yeah. So it is again what we get. Zero point 0.4 is at 0.4 steam
That's
is
it.
steam is
That's
wet. So 0.4 enthalpy we can determine after that. HF4 plus X4 into Hg4 minus HF4. So what we will get? Can anyone tell after putting these value?
466.
Yeah, 173.88 plus 0.93824. Hg4 it is 2403.1 minus 173.88. Okay. So from here what we will get? We will get H4 is equals to 2428.56 kilojoule per kg. Okay. Now H5 point. H5 point is saturated at a pressure of, we have to calculate it as a pressure of 0.008 megapascal. So H5 point it is equals to H5 point it is on the saturated liquid line. So it will be equal to HF 0.008 megapascal. Okay. So what is the value of HF? It is 173.88 kilojoule per kg H5. Okay. Now again, pump work. Pump is uh, uh, compression in a pump is a isentropic process. Okay. Or you
Sir,
can.
can we go to previous slide 1 second?
Okay.
Okay, sir.
Okay. We'll skip that because they haven't mentioned anything about here. We'll directly we know that pump work done in an pump integration VDP. Can we write like this? This is the work done in the pump or compressor. We know now from this equation for an open cycle. Closed cycle it is different for an open cycle. For closed cycle we know that work done in a closed cycle it is given by integration PdV. But in case of open cycle means like turbine and pump, those all work on an open cycle. In case of open cycle, work done is given by integration VdP. Okay, so we can directly write a pump, compressor, turbine. These all are all work in an open cycle. So what will happen? So here we can write because the integration VdP. So we integrate from a initial pressure, that is condenser pressure, to higher pressure, that is boiler pressure, V dP, because V is common. So after integration, what we will get? P only. So P condenser upon P boiler. So we will get P into P boiler minus P condenser. Okay. So it will be pump work. We can write like this because the entry at the entry of the pump, it is in the form of saturated liquid. So we will write here Vf. Okay. So what will be the pump?
सर और 2267 आ रहा है.
What? H4?
Yes sir.
22?
2267.
Okay. 2267. Na?
Yes sir.
2267. Okay.
Yes sir.
Okay. Okay. So from here, pump work, what it is? Pump work, from the diagram we know that it is S6 minus S5. So we can directly write pump work is equals to Vf into P boiler pressure minus P condenser pressure. Okay. So pump work S6 minus H5, value of Vf, it is given
1.00.
8 into 10 to power minus 3, and boiler pressure 8000. In terms of Pascal we will write
-8, sir.
0.008 into 1000. Okay. So S6 we have to calculate. H5 we already know. What is H5? 173.88. So from here if we will do multiplication, it will come 88.06, it will come. So S6 will directly come 181.94 kilojoule per kg. Or you can directly write pump work also. It will be 8.06 because it is a difference only. So you can directly write it as pump work will be this much. Okay. So now what will be the efficiency? First, as we have got the enthalpy at all the points, that is 1 2 3 4 5 6, at all points we have got. So we can now directly calculate the efficiency. So what will be the efficiency? It will be the net work upon heat supplied. So what will be the net work? Net
Now
work,
let
turbine work 1 plus turbine work 2 minus pump work. Okay. So what it will be? H1 minus H2 plus H3 minus H4 minus, what is the pump work? 8.06. Okay, directly I am putting this value, or you can first write S6 minus H5 also. So H1 minus H2, what is the value of H1? 3348 minus H2 2051.93 plus, what is the value of H3? 3353.3 minus a value of H4 2267, okay, plus 8.06. What you have got the network?
2374.8.
2374.8
74.8.
kilojoule per kg. Similarly, we have to determine the heat addition. What will be the heat addition here? First it
H1
will be
minus
H1
H6
minus S6 plus
plus H3
H3
minus
H2. Just put the values and tell me what is the value of QS. How much you have got QS?
44,000. So 4,467.47.
4,400.47.
67.47.
Just put these values here.
kilojoule per kg.
Here, just put these value now. 237.4.8 divided by 4467.47. What is the efficiency you are getting? Hello.
I am getting 53.15%.
Yeah, it is right. 53.17%. Any value 53, 53.2, 53.1, all are correct. Okay. Now the second point, what they have asked, mass flow rate. Okay. Second point, we have to determine mass flow rate. Na? So what is the power input they have given?
Our output is 100 megawatt.
Yeah. So power output they have given. So what is the power output? Mass flow rate into net work done. Okay. So what is the? It is 100 megawatt. So mega will convert into that kilowatt. So megawatt it will 10 to power 3 kilowatt it will we will convert, and watt we already know that it is joule per second. Okay, so we will write like this: mass flow rate it will be m dash, and what will the net work done we have got 2374.8 na 2374.8, it is kilojoule per kg. So what will happen? Kilojoule will cancel out each other, and mass flow rate what we will get in kilojoule per second. So what is the mass flow rate? Can anyone tell?
I am getting 1,51,591.
First, give me the value in kilojoule per second.
42.108.
40,
42.108, sir.
42.108
kg per second.
kg per second. Now we have what in the question they have asked. They have asked to calculate mass flow rate in kg per hour. So for converting seconds into hour, what we have to do? We have to divide it by, first convert second into minutes divided by 60. Now minutes it will wait, right here. So first for converting seconds into minute, what we have to do? Divided by 60. Okay. Now to convert minute into second, it will be a minute. Okay. And now minute into hour. So what will I have to do?
Divided by
60 into
3600.
60. So what it will become? So
One
R
lakh
divided by
50,000.
3600. Okay. So just multiply. Here also we have to do the same. 108 kg per hour divided by 3600. So what you will get? Just multiply 42.108 into 3600. So you will get the answer in kg per hour. What is the answer you are getting?
1
1
lakh
lakh
50,000.
So it is 42.108 15.8 kg per hour. Okay, you have to remember this value also. Okay, now third part, what they have asked? They have asked to calculate the Q rejected, heat rejected in the condenser only there. So what is the value of heat rejected in the heat transfer in the condenser?
Mass flow rate into H4 minus
Yeah,
H5.
mass flow rate. Why we are multiplying with mass flow rate? Because they have asked the that
Megawatt.
in terms of megawatt. Okay, so mass flow rate into H4 minus H5. So mass flow rate we will take this in kg per second. Okay, this value we will take. So what is the value of enthalpy? 2 to
66.4.
6.4 minus 173.88. So what is the value you are getting?
88113.
88
113.5.
point.
11 megawatts, sir.
Okay. So it is actually coming 88
113.
137.1 kilowatt it is coming. So if we'll divide it by 1000, so it will convert into megawatt. So 8.81 megawatt. Okay. Hello. Hello.
Yes,
Yes,
sir.
sir. 88 points, sir.
Yeah. It, yeah. 88. Sorry, it is 88.
Sir, for these questions, the range will be large, no, sir.
It what?
For these kind of large questions, range also will be large, no, sir.
Yeah, I'm just doing this question so that you can get 3 or 4 parts of the gate examination question only in one question. Like heat rejected in condenser, they will ask a separate question for this. What will the mass flow rate? What will the efficiency?
Yes, sir, the answer range.
Range, yeah, you will get the range also. Like if they heat rejected in the condenser, they have asked the question in the fill in the blanks type of question, then they will definitely give you the range like 87 to 89. Answer should come in this time range. If it will be anywhere near it, they'll accept it.
Yes, sir.
Always they give a range, but try to write close to 1 to 2 decimal point your answer.
Yes, sir.
Okay. Don't write the exact value like 88, write 88.1, you can write 1012, anything you can mention. They'll accept that. They give one less value, one larger value uh, according to the answer. Okay.
Yes, sir.
Okay, what is the time? It is already 7:50. So we'll stop the class here today only. Now in the next class we'll do the regeneration part, and then we'll solve all the questions related to which have come in the gate. Actually, in the gate exam they have asked more than every year they ask question. One or two problem you will definitely see of this topic.
Okay.
Hello, sir.
Yeah.
In numerical answer type questions, whenever they ask to put value up to one decimal place, in such case, if we put value up to two decimals, then whether it is wrong.
No, if they are saying that to write a decimal value, then they will give a range for decimal also. Like if they are asking such type of questions, na, wait, I'll show you. If they have asked to write you the question in the write your answer up to 2 places of decimal. Okay. So suppose your answer is coming 88.137. Okay. So you have to write 88.13 or 14. You will write this is also right. 88.13 is also right. But they'll give you range 88.10 to 88.50. This kind of range they will give 0.00. That's
So
why the range they will
मतलब
give this type.
उधर अप्रोक्सीमेशन नहीं करना पड़ेगा ना.
नहीं 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 उसमें क्या कहते हैं जितना आ रहा है आपका उतना ही लिखिए. Don't try don't approx actually at that time if they are asking in the decimal place then even though they are not asking in decimal place also, na, then also you should write your answer in decimal. Like if they will give a range of 87 to 89, and your answer is coming 88.137, then you can write 88.1314, anything you should write, but give your answer in decimal, because you don't know na, whether they will give a range this big, or they will give a range in decimal places. Okay.
Okay, sir.
Sir,
But if they are asking the question in like this, approx your answer up to two places, then they will definitely give a range like this point only, 88.00 to 88.5. Anything between this they will accept. Hello.
Yes, sir. Okay, sir.
Hello.
sir.
Yes.
Yes, sir. In actual practice, we expand the steam from the turbine up to the water pressure, sir.
What?
What is the optimal pressure in the condenser?
Actually, can you repeat the question?
What is the optimal pressure in the condenser, sir, for maximum turbine work output?
Turbine pressure.
Condenser pressure. What is the optimal lowest condenser pressure for maximum turbine work output in actual practice?
Actually,
It
that
definitely less than the atmospheric pressure, but we go what range?
answer I don't know, but I'll read and tell you in the next class for definitely. Okay. Hello.
Yes, sir.
I'll try to answer that question to you in the next class.
Okay, sir. Sir, what is the difference between the perfect gas and ideal gas?
Perfect gas and ideal gas. That part, yes, they might have told you, because it is thermodynamics, and I haven't. I have to revise that first, because I am not teaching that partner right now. So I have to revise that. Then only I can tell you, because I have also forget.
But in air standard cycles, we use the working fluid as the
I
perfect
think
gas or ideal gas.
I think perfect gas and ideal gas both are same, according to me. Only the difference comes in that ideal gas and that real gases.
Okay, sir.
I think both are same. Only the manner of telling the name is different. Because if they are mentioning in the problem, assume perfect gas, then they are asking you to take the value of Cp as 1.005 and Cv 0.718. If they'll give any like perfect or real gas, perfect gas, na, perfect or ideal gas. Assume perfect gas or ideal gas. Then they will not give you the value of Cp, Cv, gamma. In that case, since it is a perfect gas, so Cp will be 1.005 kilojoule per kg Kelvin. Cv will be 0.718 and gamma will be 1.4.
Okay, sir.
But in the I haven't seen any question in the GATE till date which they have asked any question based on the real gases. They have asked most not almost 90 to 99% I can say, they have asked the question on perfect or ideal gases only. So don't worry about that.
Okay, sir.
If they are not mentioning the ideal gas na, they'll give you the value of Cp, Cv, gamma. Okay. And
Okay.
if they are not mentioning anything, a gas enters the turbine and like that they are mentioning, then in that case you have to assume that the gas is an ideal gas. Okay.
Okay, sir.
If they are not mentioning anything, if they want you to solve the problem for real gas, then they have to give the value of Cp, Cv, gamma, because these values we have to calculate them. In that case, we cannot remember for every gas. For ideal gas, if they are not mentioning nothing, only they are saying that gas is entering, then you have to assume that it is an ideal gas, and you have to use the value of this only, Cp, Cv, gamma of ideal gas. Okay.
Okay, sir.
Okay. Okay. So in the next class we'll do the regeneration part, regeneration in the Rankine cycles, and after that we'll solve the problems. Okay. Problems will be like this only, like the one big problem we have done na? So they will ask this big problem only in part wise, like they will like the efficiency 2 marks, mass flow rate, calculate mass flow rate 2 marks, 1 marks, like this they will only ask. The biggest problem which comes in the gate exam is na, that they play with you in the units. Suppose in one question they have mentioned you each and everything in. Wait, I'll give an example. In suppose in a questions are simple only. Suppose in the question they have given every value in kilowatt. Okay, and then in the option you will see they will ask the question in megawatts, gigawatts, and once you calculate, suppose your answer is coming 108. Okay, so one of the answer might be there also, like 108, 1080, 1080, like this. And if you get 108 here, you will take this only without reading the units. So you have to see the units also first. Third option they will give 108 kilowatt. Okay, so always remember the units which they have asked to calculate, because in the gate exam when I was giving, I mm, I calculated all the values correctly, and my answer was also correct. But the only problem came was that I didn't read the unit which they have asked, and in that manner I lost around 7 to 8 marks in gate exam. That 7 to 8 marks I lost, and plus minus marking, so around 10 marks I lost. I think I got 73 or 74 marks. I should have scored above 80 in that exam. Hello.
Ah, yes, sir.
Yeah. So please remember that units. It is very important while doing the problem. Okay, so we'll stop class here only. Already 2 hours are over.
Okay, sir. Thank you, sir.
Okay.
Thank
Okay.
you, sir.
Okay. Thank you.
Thank you, sir.
Thank you, everyone.
Thank you, sir.
Thank you. Thank you.